Welcome to the new lesson. In our previous lesson, we learned how to represent a graph in programming, and there we had two approaches. One was the adjacency list, that we used object in order to represent a graph using its adjacency list, and the second approach was adjacency matrix, that we created a two-dimensional array, and then we define the relation or the connection between those nodes. Today, uh, I will go through graph traversal algorithms. That means when we try to search or traverse our graph, there are two popular approaches that we can traverse a graph. One is the breadth first search, and the other one is the depth first search. It is not limited to these two, but these two are the optimized approaches. If we use these two approaches, we can traverse the graph efficiently. So there are several examples to explain how BFS and DFS works. However, right now I will focus on explaining BFS, breadth first search. Based on our knowledge from our previous lessons, breadth first search is a kind of search that explore the given data structure level by level. That gave more clear meaning when we were working with tree. We were saying level by level. Right now, in graph, also it is like that. For example, if you consider this graph and start from number 1, so when the process number 1, then it starts the second level, which is 2 and 3, 5, and then when this level is finished, it goes to the next level, 5 and 3, and then to the last level. That is how BFS works. And also, based on our knowledge from our previous lesson, in order to implement BFS, we use a queue data structure. In a queue data structure, you know that the first node inserted in the queue first, that node is extracted or removed from the queue first. So, however, here we are adding one more point, and that is using a set when we traverse or visit our nodes in this graph. When we were working with tree, we did not use set because at that time we did not need that. But here with this graph, that it doesn't have a specific amount of or generally here we don't have the concept of left child, right child, and parent child relation. We have the parent child relation, but here we are not focusing that much because that doesn't help us a lot to traverse this. However, when we start traversing our graph, there is a possibility that we may visit one node many times. So we use a set to keep the track of visiting the nodes in the graph and avoid repeatedly visiting them. So I think if we write a code and explain that, that would be much better. Let's consider this graph, and considering that graph, let me first of all, let me create a queue. Let's consider this is a queue, and also let's consider this is a set. Okay, so now, and in this graph, we already know how to represent a graph, and right now I am working with the adjacency list and implementing breadth first search on an adjacency list. On the next lesson, we will work breadth first search with adjacency matrix and also DFS with adjacency list, also DFS with adjacency matrix. But right now I will focus on using BFS with adjacency list. Here I have a graph. First I represent this graph using its adjacency list, and we use an object for that reason. You know how to create an object in JavaScript. For example, const adjacency list equals. So first we consider all the nodes in the graph as a key, and their value can be the list of other nodes which this key have connectivity to those nodes. For example, node number 1 has connectivity to node number 2 and node number 5. So node number 2 and node number 5 are its adjacent nodes, and they create this adjacency list. So this way we continue creating the key, and its value is the list of nodes that this key node has connection to those nodes. Well, I have that here. I directly copy that. I don't need to write them individually. That takes time. So now here you see all the nodes are used as a key, and their value is a list of other nodes that this key node has connection to those nodes. So now you might already know how to work with objects in JavaScript. However, if you follow BFS approach, it is a more efficient way, and you can traverse your graph more efficiently. Okay, so now first I create a queue inside the BFS function. Const BFS equals okay. So most of the time it is a good practice to pass the starting node to this breadth search function. So you can pass the starting node from anywhere that you call the function. So first of all, we need to create a queue. Const queue equals, and the first node that we add in the queue is the first is the starting node, which is already given here in the parameter. Okay, start. This one is acting as a queue, and we created that. Also, we need to create a set, because as soon as we processed a node, we don't have to reprocess that, because there is a possibility that one node may get inserted twice, 3 times, or more times in the queue, because we process the queue, the nodes in the queue based on following the approach of processing a node and then processing its adjacent. So at some point, maybe one node be adjacent to many other nodes. For example, here, let's consider number 5. Number 5 is adjacent to number 1, it is adjacent to number 2, and also it is adjacent to number 4. That means number 4 has connection to this, number 2 has connection to this, number 1 has connection to this. So when we are processing number 1, and when we start processing its neighbor, that means we process 5 also. So when we process 5 here, and when next time when we come to number 2, or when next time we come to number 4, we don't need to repeatedly process number 5. For that reason, we need to create a set to keep track of the visited nodes and avoid repeatedly processing one node. So const visited equals new set. I'm using set because in the set we don't have duplicate values. So now that we have our queue and we inserted the starting node, let's start from processing number 1. I inserted number 1 here in the queue. Okay, number 1 inserted in the queue. And also I considered number 1 as a visited node also, so I insert that number 1 here in the set also. So Now I'm saying as far as the queue is not empty, we have to keep processing. That means there are still some nodes that we have not processed. So we say while queue.length is greater than 0, we have to keep processing. So we have to extract the node from the queue and process this. So we can say let current equals queue dot shift. Okay, so when we call this queue dot shift, that means we remove number 1 from here, from the queue, we extract that. So now that we extracted number 1, we do our process, and as soon as we process number 1, then in a breadth first search, we move ahead level by level. What does that mean? That means when you process number 1, then you have to find all the nodes which are adjacent to this one, and that creates the next level. So here you see in the list we have all the neighbors of number 1 as an array here. So if there is an array, easily we can create a loop here and process all the arrays, all the nodes which are in this array, and they are the adjacent to the node number 1. So after processing number 1, now let's process its neighbors. So I'm saying for let neighbor of. So here we have this list here, and we need to use this list. So let's use this adjacency list and call only this key number 1 that we have here, and then the value of this key is a list, and we can loop through this. So let me call this one adjacency list. Adjacency list, the value of number 1, the value of this number 1, this node, and it is this list. Okay, so now we check the neighbors if they are already in the visited list or not. If they are already added in the visited list, that means they are processed at some point. But if they are not here in this visited list, that means still they are not processed, so we have to process them. So first we check if it is not in the visited.list, if this neighbor, for example, we are at number 1, at number 2 now, if this neighbor is not in the visited list, so we have to add, that means that node is not processed yet, so we have to add that node to the queue. So we say queue.push this neighbor, queue.push this neighbor, and that neighbor is number 2, so we add number 2 here, and also as soon as we add them to the queue, we add them to the visited list also. So I add to the visited also, visited.add neighbor. So I added number 2 to the neighbor also. Okay, so this for loop continues. First it check number 2, and the next time that it continues, it comes to number 5. This time, if visited.has number 5, it checks that if number 5 is already added in the visited list or not. So if it is not, so add this to the queue also. Right now we see that number 5 is not here in this visited list. So now add this number 5 to the queue. And also add this to the visited list also. Okay, so here we add the number 5 or the next neighbor in the queue, and here we add that neighbor in the visited list. That means we have visited number 5 also. So this time that the loop comes here, so this loop only executes 2 times because we have only 2 elements. So when this is executed, then again the while continues. This time it says that while q.length is greater than 0, now the length is 2. That means still it continues. So we remove the first inserted node. That means number 2. So we remove number 2 from the queue. And when we removed, then we make here some process, any process, like we check that we get the value, whatever purpose we need that. And then we check its neighbors. So if we want to check its neighbors, then we have already this object here, and we have the neighbors of this number 5 here. It is the neighbors of number 5. So it is an array. So I have to get this array, and this array is a value of this key and this object. So I can easily call this object and get the value of the given key node. So I start processing on the neighbors of number 2. Sorry, we just removed number 2. Number 2, its neighbors are here. So the first node in the list is number 1. So we say, does this visited list have the number 1 already in itself? We say yes, it has. So if it has, we do not add it repeatedly to the neighbor, to the queue, and we do not add it to the visited list. See here, we are using this visited set just to avoid repeatedly processing one node. Here it avoids that. For example, number 1 is already processed, so we don't need to add number 1 again in the queue. Okay, so there's doesn't execute, it comes to the next one, and the next one is number 3. Let's check, is number 3 already visited? We see it is not visited, so if we add number 3 to the queue, and also we add number 3 to the visited list. Okay, so the loop continues, comes to number 5, and it checks number 5 is already added in the visited list. We see that number 5 is already in the visited list, so this loop does not continue, and that was the last node in this neighbor. So again the while continues. This time q.length is greater than 0. Yes, it is 2. So it removes the first inserted node, and that means that is 5. So we remove 5 also from here, and then we check its neighbors, and the neighbor of number 5 is a list here. So it is also an array, and we have to get this array from this list, from this object. So when we get that list from that object, we check each of them, and the first one is number 1. We check, is number 1 already in the visited list? We come here and we say yes, so we do not add this to the queue, and we move to the next node. The next node is number 3. Is number 3 already in the visited list? It says already it is visited, so we do not again add this here. And now number 5, is number 5 already in the visited list? It says yes, it is already added, so we do not add them repeatedly, and the for loop ends. So it comes again to the while loop. It says q.length is greater than 0. Yes, we have number 3 still, that is number, the length is 1, so we remove that one from here, and now we check the neighbor of number 3. The neighbor of number 3 is 2 and 5. So we check first number 2. Is number 2 already added in the visited list? Yes, it is already added, so do not execute. Go to the next node, number 4. Is number 4 already added in the visited list? We see it is not added, so we add this to the queue. Number 4 added to the queue. Also add number 4 to the visited list. Okay, so it was the last node in the adjacency list, so the loop finishes. And again we come to the while loop. So it checks q dot length is greater than 0. Yes, it is 1. So we remove that from the node. We extract that from the node. And now we need to check, or we need to get its neighbors, and its neighbors are 3, 5, and 6, which is a list. So how do we get this list from this object? So we call this object, and then we pass this key, and we receive its object. So, and the list is 3, 5, and 6. So at this time, when we loop through this list, the first is number 3. Is number 3 already in the visited list? Yes, so we do not add this to the queue. The next is number 5. Is number 5 already in the visited list? Yes, so we do not add this to the queue. The next is number 6. Is number 6 already visited in the... Is it already visited? We say it is not visited. So we add this to the queue and the visited list. So now let's add number 6 to the queue and number 6 also to the visited list. Okay, so this time we check the while q.length is greater than 0. Yes, it is 1. So again we extract this. So extract that from the queue, and now we check its neighbors. So the neighbor of that node is only 4. Is 4 already added in the visited list? Yes. So now at this time when we check that the length of this queue is 0, the loop finishes, and here in the visited list we have all the visited nodes. That means this way we could easily search or traverse our graph from the first to the last node, level by level. I hope it was clear enough, and in case you have any questions, you can add your questions in the comment, and I will come to those questions next time. Have a nice time until the next lesson.